and welcome back to Calculus 2, section 7.5, integration by partial fraction decomposition. So, some of you, hopefully, seen this procedure already in your pre-calculus class. For some of you, this will be brand new. This is algebra intensive, not hard by any means. You have to remember, though, that if the exponent in the numerator and exponent in the denominator are the same, or the numerator is larger, you have to do long division first. So you can only do partial fraction decomposition if you have multiple terms, multiple factors in the denominator, and if the overall exponent is smaller than the numerator. First of all, what is partial fraction decomposition? Think about having 3 over x minus 2 plus 5 over x plus 1. And now you want to add these two. Well, that should not be too big of a deal. You know that you are supposed to cross multiply, get the common denominator. So you will have 3x plus 3 plus 5x minus 10. And when you combine all of this, you have 8x minus 7 divided by x minus 2x plus 1. So what I've done here, going this way in calculation, was to add two rational expressions. If you have this and you have to go back, it's a partial fraction decomposition. So partial fraction decomposition is backwards procedure from what you've seen in algebra, which is what I demonstrated. So you are given 8x minus 7 over x minus 2x plus 1. You are given that, and you are supposed to come up with two fractions that would give you that when they are added together or subtracted, whatever. So how is that achieved? Well, it's a procedure. You will have to memorize 4 setups that you will use, which are quite easy. And then you compile the setup, you grind through a ton of algebra, and you have the result. Then you can integrate. So each problem should take about 35 to 70 minutes. So let's see the procedure. 8x minus 7 over x minus 2, x plus 1. Now I will put these later in a box telling you memorize this. Right now I will tell you that your setup looks like this. A over x minus 2 plus b over x plus 1. So both of these terms, x minus 2 and x plus 1, are linear, right? X to the first power. So the setup for the linear term looks like this. A over, right, so some constant a. Now this is also a linear term. A is already used up, go with the next letter. If there was a third, you can have as many of these as you want, right, here. So if you have a third one, it will be c over the third one, and so on. So now that I have this, I add these together, and I get x minus 2, x plus 1, and then I have ax plus a plus bx minus 2b. So I hope you see what happened. I set these up, and then I combine them there. So now I can compare these two worlds. I clearly see, I don't know if you clearly see, but I clearly see that ax plus a plus bx minus 2b is equal to 8x minus 7. Because denominators are the same, we don't have to worry about that. Worry just about numerator. So when I compare those two, this is what I get. And here is the $1 million trick. Guys, look at this. I have two terms on the left-hand side which contains x and one on the right-hand side. Those are the ones that I want to compare. So what do? I say, let me factor x. And when I factor x, I have a plus b. And then plus a minus 2b is equal to 8x minus 7. And now I'm going to color code. Coefficient of x is compared to coefficient of x, and the constant term is to compare to constant term. This is where you get your equations. A plus b is 8. A minus 2b is 7. Subtract the equations because they already have a and a the same. You don't have to go through multiply by -1 and then add 15 steps. Just subtract the equation till a, right? If you have two values that are identical, just subtract them. You will get 0. If you have the same number with opposite sign, then add them, and they again go. So a minus a is 0a, b minus 2b is 3b, and that's a -7 here, because you get 15. So 8 minus 7 is 8 plus 7, which is 15. So we got b. B is 5. Now we know that a plus b needs to be 8. So how much is a? 3. So now we have the setup. A was 3 over x minus 2 plus 5 over x plus 1. We got the a and b. Is that true? Oh, hell yes, it's true. See there, right there. So that's what the procedure of partial fraction decomposition is. Why are we doing this? If you have integral of 8x minus 7 divided by x minus 2x plus 1 dx, observe that u sub doesn't work. It's not the basic integral. Trig sub, forget about it because you don't have any of the squares. Yeah, we don't have to have a square root, but you should have, x squared minus 100 or something. Nothing that you learned so far works. But when you perform partial fraction decomposition, you get this. Integral, open parenthesis, 3 over x minus 2 plus 5 over x plus 1 dx. Now what? U sub, it's ln's, exactly. So you can just write immediately 3 ln x minus 2, don't forget absolute values, plus 5 ln x plus 1 plus c. And problem solved. This integral looks so easy, right? Well, there is no free lunch. Insert work here. These problems do take a page because this is the work that you had to do right here. This is the work that you had to do that happens in between these two equals, in between the equal sign there. Awesome. So let's see the setup, memorize the setup. You hopefully have them on your class preps because it's extremely important. Partial fractions, setup. So if you have some kind of blah over x minus c, the setup is a over x minus c. This includes 1 over x, right? Because 1 over x, that x is x minus or plus 0, whatever. So c is 0 in that case, but it's still linear. So if you have any, we don't care what's up there for the setup, right? We had this. I'm writing blah now, but it was this. That doesn't impact the setup at all. It's the factors in denominator and how they look, which impacts the setup. So that's why I'm writing blah. I can also have blah over repeated x minus c squared. If you have that situation, then it's a over x minus c plus b over x minus c squared. If you can't factor quadratic, so a x squared plus bx plus c, then you have ax plus b divided by ax squared plus bx plus c. So that's the setup. Now, what qualifies for this? Anything that will produce complex numbers, like x squared minus plus 100, that's going to produce complex answers. You can't factor that one. So x squared minus 100 you can factor, x minus 10, x plus 10, and you can unleash the procedure using the basic ones. But for certain ones, you can't factor them at all. They factor over complex numbers, in which case you have to use this. And the last one is a repeated, so blah over ax squared plus bx plus c squared, which will give us ax plus b over ax squared plus bx plus c, and then plus cx plus d over ax squared plus bx plus c squared. And now you see all 4 setups in one spot. Yes?
For the first 2 cases, does it have to be x minus c, or can it be x plus c?
X plus c, yeah, sure, it's fine. Anything.
Okay, so
Because c can be negative 3, and then minus and minus, right, plus. Guys, this is what you're memorizing. That's what you're memorizing. And you practice the setup. Once you are able to set the problem up, then you should be able to solve. And then once your partial fractions are done, then you go on and you integrate. I wish I could find that problem which had almost all of the integration techniques in it. You do one, and then you do the other, and you do the other, and you finally see U sub at the end, and you're like, I know it's done. Yes? Nothing? Yeah, okay. No. All right. I'm going to write this on a board now, and then I'm going to write it on a tablet, because I want you guys to see both things at the same time. For those millions of viewers that we have, just pay attention to what I'm saying and write it down. So I'm going to write blah divided by long division line, because I want to put 3 different parentheses here. First, I'm starting in denominator with x, open parenthesis, x plus 3, and then another parenthesis that says x squared plus 36. So denominator is x times x plus 3 times x squared plus 36. X, open parenthesis, x plus 3, close parenthesis, open another parenthesis, x squared plus 36. So I just want to write the setup for this. I'm not solving because I put blah up there, so I don't know anything up there, so I can't solve it. I can only set it up. And this is going to be one of the questions for the exam. One question will say somewhere, integrate, and you will recognize partial fraction decomposition because you studied and you will do it. But one problem will give you something horrible, much worse than this, and you just need to set it up and walk away. for like 5-6 points. So what are we doing here? The first term is linear, so a over x. That's it. The second term is linear, so b over x plus 3. And the last term is what? Square. So we have cx plus d on top divided by x squared plus 36. So I used the first one twice and the third one once. That's just the setup. Fair? No matter what you're given, if you can't factor it any further, you have to do it. Now, I want to show you immediately underneath this example, copy the same problem, just put the minus in the last parenthesis. Yeah. So now, this one factors. And because it factors, it introduces another 2 linear terms, which are all different, no repeats. So now we have a over x plus b over x plus 3 plus c over x minus 6 plus d over x plus 6. So I hope you can see that the little change yields a completely different setup because you have different creatures in the game. Yes?
You don't have that much numbers in the numerator.
What?
Like, if there, I mean, if the numerator is really small, like there's no place to put C or D, what do you just put in?
What do you mean numerator is small?
I mean, instead of,
They're zeros.
no, in this case we had 8x minus 7,
Yes.
so if that's 8x minus 7, we block.
But they are called coefficients for x cubed, x squared, x, and right? There are 4 coefficients. They don't exist, they have the zeros. We'll see that. The example is coming. So, you have to memorize this. I'm going to box this. Because these are your setups. And now we're going to do more examples. It's just algebra, 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 algebra. Partial fractions. Forgot that this section goes forever until I get to homework. There we go. All right, so let's go with, let's say, problem 28, because we can. All these problems are the same as soon as you figure out how to set it up. So problem 28 says 16x squared divided by x minus 6 and then x plus 2 squared dx. Well, we immediately set this up as a over x minus 6 plus b over x plus 2, and because there is a repeated, plus c over x plus 2 squared dx. So we use the first and the second in this case. See this second? This one? It was a repeated one, because we had x plus 2 squared. All right, so now what do? We multiply here, look for common denominator, do all of that stuff. So we are supposed to compare 16x squared over x minus 6, x plus 2 squared, to a over x minus 6 plus b over x plus 2 plus c over x plus 2 squared. So now, usually when I teach this in algebra, I say, let's play the game of what's missing. You know what the common denominator is. It's given to you on the left. So you compare that to your expressions on the right and multiply numerator and denominator by exactly what's missing, term by term. So we have x plus 2 missing, x plus 2 squared, sorry. On the second one, I have one x plus 2. I need one more, and then x minus 6. So that's x minus 6, x plus 2, and x minus 6, x plus 2. On the last one, I have x plus 2 squared. All I need is x minus 6. So as you can see, all I did is I multiplied each term individually by what's missing to create the common denominator. This being common denominator. So for the first term, I have this, and I don't have that piece. So that's why I'm multiplying top and bottom by the piece I'm missing. And you go across in the same fashion. So now we can ignore denominators because it's common denominator everywhere. We will say 16x squared is equal to, and now we have to FOIL all of these and then put x squares on the top of each other, single x's on top of each other, and the constants on top of each other. So what do we have? X squared plus 2, so that's going to be ax squared plus 4ax, that's the middle term, plus 4a, that's the last term. Then the next part is to FOIL x minus 6, x plus 2. Now, if you know your algebra, obviously, you can just look at it and write it. Because we know for factoring, right, we look at these two numbers to add and subtract and do those kind of things. So it has to be x squared minus 4x minus 12. Plus bx squared minus 4bx minus 12b and then we have the last one, which is c. Oh, that's easy. Cx minus 6c. I observe that I have terms with x squared, and that I have terms that only have x, and the terms that do not have anything in terms of these things. So 4a, so on. So that's the constant term. So let's go. Factor out a plus b for x squared plus all of the terms that are checked off, which is 4a, and then minus 6, no. So 4a minus 4b, right? And then plus c. And then plus, what's left over is the ones that are not checked at all, which is 4a minus 12b minus 6c. Now what is this equal to? It's equal to 16x squared, and just to make some of you happy, plus 0x plus 0. I said sum. So now we are comparing. We compare coefficient of x squared with coefficient of x squared. A plus b is 16. we compare coefficient of x with coefficient of x, which means 4a minus 4b plus c equal to 0. That's it. You have two equations. Oh no, you need three equations because you have c. So 4a minus 12b minus 6c is equal to 0 as well. Now we have a system of three equations, three unknowns, and whatever magic works, use it. I clearly want to eliminate c from by adding these equations because the a plus b does not have c in it. Now, good practice is always to copy first equation, and when I multiply by 6 I get 24 plus 4 is 28a. 6, that's 24 minus 12 is, no, that's negative 24, negative 36b, right? And then 6c will die, equal to 0. What happened? All good?
Yeah.
So times 28 on top. So that's going to be 28a plus 28b equals to 28 times 16. $448. And we have 28a minus 36b equal to 0. Subtract the equations. A's die. This will add to 64. B equals to 448. And the answer is clearly 7. Now a plus b is 16. So a plus 7 is 16. A equals to 9. Note that I'm not boxing them because we're not right. Not there yet. I need C. 4a minus 4b plus c equals 0. 4a, what did I say? 4a minus 4b plus c. Plug in b, plug in a, come up with, so a times this 36 minus b times 428 equals to negative c, right? Move c to the other side. So 36 minus 28 is 8, so c is negative 8. All right, we're done with partial fraction. Now we need to plug this in and do the integral. Did I mention about carpal tunnel? Yeah, I said that, right? Did I mention that each problem is 35 minutes? I think I said that too. Did I mention that we might be here on Thursday? Yeah, I did too, right? So now we go back looking for the integral. There it is, ABC. So now this becomes integral of A, which is 9, over what? X minus 6. And then we have plus B, 7 over what? X plus 2. And then we have minus 8 over X plus 2, everything squared, all of that dx. Now all we need to do is to integrate each one of these. This is three separate integrals, technically. First two are easy, right? No problem, the first two. Well, all of them are. 9 ln x minus 6 plus 7 ln of x plus 2 in absolute values. And now, what now? U sub, exactly. So u equals x plus 2, du equals dx. So we have negative 8 integral of u to the minus 2 du. I skipped like only 2 steps, it's not a big deal. Integral of this is u to the minus 1, so negative 1 over u, which is x plus 2. And we have plus c. So final answer, 9 ln x minus 6 plus 7 ln x plus 2 plus 8 over x plus 2 plus c. They all have these wonderful answers like this. Oh wait, when your inverse tangent hits on these ones. And it does. Just think of the one that I mentioned earlier, guys. When you have something over x squared plus 100. Does this look like x squared plus 10 squared? Is that our tangent when you integrate? Hell yeah. So you gotta be on lookout for those. All right. One more example. We have time?
No.
What do you mean class is over? It's like, isn't that 7:50 or no?
7:20.
Oh, 7:20. Whoa. Well, I'm not gonna say I'm sorry. I'm not. Yeah. It's like what? It's Thursday night. Like, what are you gonna do? What? Right? And the whole next week possibly wasted. Right? So, all right. Bye, stream.